Hello all, welcome to the subject of microcontroller. I am Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parvati Bai, Ganma Mujik College of Engineering, Wagoli, Pune. So today in this lecture, we are going to see about the analog to digital converter of 0809 and how we are going to interfacing this to microcontroller. So let's see what is analog to digital converter. A large number of analog to digital converter ICs have been produced with many manufacturer companies like a National Semiconductor, Motorola, etc. to meet the various demands such as speed and response, resolution and compatibility, and easy of the interfacing with the microprocessor. The National Semiconductor produces this analog to digital converter 0809, which is an 8-bit and analog to digital converter, whereas Interstyle produces IC7109, which is a 12-bit analog to digital converter. So this is the analog to digital converter, yeah. So this analog to digital converter is a 8-bit. This is the 8-bit analog to digital converter. There is another IC, like a IC 7109, which is 12-bit. But our ADC 0809 is a 12-bit. So this is a 12-bit IC. Let's see what of the principle of A to D conversion in this 0808 or 0809. So these operates on the successive approximation technique of analog to digital conversions, and it is a CMOS device. These are the CMOS devices which is having 8 analog input channels. Here, this A to D 0809, which is having a CMOS devices and which is having 8 analog input channels, and with the channel selector is also there. The channel will be selected with the multiplexer with a multiplexer technique, and which those are very compatible, control signal. Those are also having very compatible control signal to interface this A to D with a microprocessor or controller. Here n is equal to 8 is nothing but 8-bit 256 registers voltage divider. Register voltage divider is there, and a group of switches, also a group of switches. A group of switches see the A to D, which is a 8-bit, and the similar ICs of A to D. The name of IC is 7108. This one is a 12-bit, but this 0809, which is a 8-bit. CMOS analog to digital converter, which is having 8 input analog input channels with a multiplexer. The input can be selected by using a multiplexer, and those are also having the control signals, and those control signals are very compatible to interface this A to D A analog to digital converter to microcontroller or microprocessor. And also which one is having 8-bit 256 registers voltage divider, and also the group of switches is also there. However, there are 8 analog channels. We can connect up to 8 analog input to this IC. And due to use of the multiplexer, at the time only one analog input will be converted into the equivalent 8-digit output. The analog input channel can be selected using 3 address line A, B, C. There are 3 address line A, B, C, and the input can be selected by using a multiplexer. At a time only one output will be present in the form of 8-bit digital output. Single input is connected at the output at the time, and the output in the form of 8-bit digital output. So this is the information about this ADC 0809. Let's see some features also. What are the features of analog to digital converter 0809? Right. 0809. Let's see first feature. Similar as we have explained, having inbuilt 8 analog input channels. Those are the channels, and which operates up to 5-volt voltage supply. 5-volt voltage supply. And third one is the output is TTL compatible. The output is TTL compatible. And fourth one is the operating speed is high. High operating speed. Fifth one is which is having 8-bit resolution. And another one is which is having low power consumption. Low power consumption. Easy to interface. Easy to interface. Easy to interface with the microprocessor or microcontroller. So in this case, we are going to interface with the microcontroller. Minimum temperature dependence. Minimum temperature dependence. These are some features of A to D converter. So let's see the pin configuration of analog to digital converter. Let's see the pin configuration. There are 2 to 8 analog input terminals are there. So here the pin number 1 to 5, the pin number 1 to 5 and 26 and 27, 26 and 28, sorry, 26 to 28. So these pins are designated as IN 0 to IN 7 or 8 analog input of the IC. So we can connect the signal coming from the 8 different transducers to these pins. Each one of these input will be converted to the 8-bit equivalent digital. So, however, these input are converted into the digital form one by one and not all at the time. Hence, one of these 8 input should be selected for the conversion, and this selection is done by mean of the address pins A, B, C. See, A, B, C. So this is table shows the analog channels which is from IN0 to IN7. So from IN3. So IN3 to IN7 which are allocated at the pin number 1 to 5 and the starting IN0 and IN1, IN2. These pins are allocated at the pin number 26 to 28 of the IC. So rest of the pins are A, B, C. Those are the address pins. These pins will be used to select the particular input channel. These inputs are converted into the digital form one by one, not all at the time. So one by one, the channel will be connected. Hence, which will produce the digital form of the output. Hence, these 8 inputs should be selected by this using ABC address pins. So, ABC address pin number is 23, 24 and 25. These pins will be decide or select one out of the 8 analog inputs for conversions into the digital form. So, for example, C equal to 0 and B equal to 1 and A equal to 0 is nothing but what pin is going to select here? IN pin 2 is going to select. If those all are 0, then IN 0 is going to the select and 001. If such combinations, the signals is present at this input terminal, then IN 1 is going to be select. And the analog signal at this input and is converted equivalent digital form. So accordingly, the configuration of this, according to configuration of this data on these pins, the particular input pin is going to be select and finally which will analog signal will be converted into the digital form. So let's see reference voltage. Reference voltage here V refer plus and V refer minus. There are 2 reference voltage terminal are there. See here pin number 12 and pin number 16. Pin number 12 and pin number 16. So depending on the desired polarity of the reference voltage, we can connect the positive or negative reference voltage externally to these pins. See here, according to the polarity of the voltage, we are going to connect the reference of these pins using these pins. The next ALE and output enable. Here, where is the ALE pin? See, address enable latch ALE and output pins. Output enable. So ANE and output enable, these 2 pins These two pins are called the address latch enable. Input is useful in enabling the address latch which stored the address on the line ABC. The output enable pin when activated while making the digital output available on the output pin. So these pin are acts as a latch. See, when the address is available at the pin ABC, then this pin will be going to high and unable to access the address. And after that, if the digital, after connecting the input, the analog signal will be converted into the digital form. Then after converting digital form, we have to access those signal from where output terminal. So output enable pin. When the output enable pin is activated, then only digital output is available at the output pin. So these are the functions of enable latch and output enable. So this is the block diagram of ADC 0809. Here the input pin shown from IN0 to IN7. These are the analog input, and inside the multiplexer operation is there. So particular at the particular time, the one input terminal will be connected, and the address line will be ABC, and accordingly these address line, the input will be selected. If ABC 00, then IN 0 will be going to select. If the all are 0 0 0, then this will be going into selected and convert the analog input to digital output and available at this output terminal. And the ALE pin is there. Here ALE, when address is present on these terminals and activating the ALE, then only the input will be going to access. Then after the output is ready on this output terminal pin, and those can be accessed when this pin is activated. Then only the output will be we can access. Start and KEOE. We have to enable the start input to begin the A to D conversion, and a pulse is to be given to start the pin to start conversion, and the end of the conversion is indicated by NEOC output. See here, there are two input terminal, that is a start, and sorry, there are two terminal, that is start and another EOC. So after accessing the input terminal, it is start to converting from analog to digital by activating this pin. When high on the start pin, and to start this pin, we have to apply the pulse to this terminal. After applying clock, it will start converting. After conversion process, it will become indicated by this pin. End of the conversion, it will become high, and it will indicate that the conversion process is over. And the digital output pins, the digital output pin number 17, 14, 15, 8, 18, 19, 20 and 21. These are the digital outputs. Here there are 8 digital output pins, and the 2 is to -1. This is indicates this is the MSB bit, and this is the LSB bit here. This is the MSB and this is the LSB bit. Then this is the information about the block diagram, which is having 8 analog input channel and 8 output terminals, and 1 analog and 3 address terminals is there to perform the multiplexer operation. The bits depending upon that the particular input channel will be going to connect, and After ALE pin is activated, then it will going to connect. And after connecting the input channel, the input signal is available now. Then we have to start the conversion process by activating this pin. This pin will be activated. This start is will be activated by applying clock to here. Then after conversion process will be start. After conversion process, it will indicate that high by end of the conversion. After end of the conversion, the output is available at the output terminal. Here 2 is to minus 1 is nothing but MSB bit. The digital output will be available. 2 is to minus 8 is nothing but which is LSB bit. So the and output only the output is present at the output terminal. It can be accessed by after enabling the output enable. If output enable is active, means you can access these outputs. So this is the information of the pin diagram. So here RF and RF positive and VRF negative. VREF positive, VRF negative means nothing but these are the polarity reference voltage. We can connect to a positive or negative voltage externally to these pins. We can connect the voltage externally to these pins according to the polarity. Now let's see interfacing of analog to digital converter with the 8051. Here the figure shows the interfacing of 8-channel 8-bit analog to digital converter to 8051. And here the ADC 0808 has an 8 input channels. Hence, in order to select an input channel, it is essential to send 3 address on ABC inputs. The address of the desired channel is sent to the address pin through the port P20, P21 and P2.2. So this is the 8051 microcontroller. So port 2.0, port 2.1 and port 2.3. Here the port 2.0, port 2.1 and port 2.2, these pins are connected to the here ABC address pin of analog to digital converter to select the appropriate input. Then we have to wait 50 nanoseconds for the address that must be latched, and it can be obtained by sending ALE signal. So after connecting, we have to wait for 50 nanoseconds. Then the address will be become latched by activating the ALE pin. After activating ALE pin, then after activating ALE pin, then only the address will be accessed by this. The address will be accessed by this